Have you ever thought about why we humans aspire to space? We are on the verge of colonizing the moon and Mars. But why aren't we actually exploring Venus, if it's much closer to Earth than Mars? The travel time to Venus would be much shorter with a favorable constellation, and yet we only send a probe to Venus once every 10 or 20 years. Venus could once have been very similar to Earth. Computer simulations have even shown a frightening resemblance. The only difference is that Venus has undergone a greenhouse process that has dramatically changed its surface. Our home planet is also currently undergoing serious changes to its atmosphere and climate, and we have to ask ourselves, are we facing the same fate as Venus? And shouldn't we know much more about the planet for this very reason? With a diameter of around 12,104 kilometers, Venus is almost the same size as the Earth, which has a diameter of around 12,742 kilometers. The mass of Venus is about 4.87 times 10 to the power of 24 kilograms, which corresponds to about 81.5% of the Earth's mass, 5.97 times 10 to the power of 24 kilograms. Both planets have a similar density. The Earth has an average density of about 5.52 grams per cubic centimeter, while Venus has a density of about 5.24 grams per cubic centimeter. Both Earth and Venus consist mainly of a mixture of iron, oxygen, silicon, and magnesium. Both planets have a similar internal structure with a core, a mantle, and a crust, and both planets have an atmosphere, although the composition is very different. Despite these similarities, we humans are not drawn to Venus. We would rather colonize Mars. Mars is only about 6,779 kilometers in diameter, making it much smaller than Earth and Venus. There are no recognizable geological processes on Mars. Venus, on the other hand, is seething with volcanism, and we have observed signs of plate tectonics. Mars probably lost its atmosphere millions of years ago. Today, it's a dust-dry and actually barren planet, yet it magically attracts us humans. We have placed dozens of probes in orbit and on the surface of Mars. 5 nations are currently exploring the planet, and more countries want to join the Mars exploration in the near future. Venus, on the other hand, is usually only casually visited by probes as they use the planet's gravitational field for flyby maneuvers. The last images of Venus, for example, were taken by NASA probes that flew to the Sun and Mercury. This lack of interest in our sister planet can be upsetting, but there is a good reason for it. Hot, toxic, and corrosive. If Earth meets the same fate as Venus, we humans will really only have a short time left to enjoy our planet. Venus is an extremely inhospitable planet. Among the rocky planets, it's the hottest, most toxic, and most corrosive place in the solar system. With surface temperatures sufficient to melt lead and atmospheric pressure 90 times that of Earth, it presents an enormous challenge for space travel. These extreme conditions not only make it difficult to land probes or rovers, but also make it almost impossible for technical facilities to survive on the surface of Venus in the long term. The atmosphere of Venus consists mainly of carbon dioxide and is surrounded by dense clouds of sulfuric acid. This mixture leads to a strong greenhouse effect, and the dense atmosphere makes it almost impossible to examine the surface with radar technology or telescopes. It's a miracle that a few probes have nevertheless been able to withstand the surface temperature of around 465 degrees Celsius and the toxic vapors for an hour or even longer. Venus, too inhospitable for life. We humans don't just explore space to satisfy our curiosity. We are looking for alternatives if, in a few thousand or 100,000 years, our Earth becomes as inhospitable a planet as Venus is today. Venus would hardly offer us an alternative, but Mars would, and so it's obvious that we would rather put our efforts and financial resources into exploring Mars than a planet that is absolutely hostile to life. With average temperatures of around negative 63 degrees Celsius, violent storms, and a thin atmosphere without oxygen, Mars cannot exactly be described as a cozy place. But unlike Venus, it offers conditions that fall within the range of what is tolerable for humans. Another point that speaks against the habitability of Venus is the lack of water in liquid form. Water is a fundamental prerequisite for life as we know it. Mars, on the other hand, shows traces of former water courses, and there may be large deposits of ice beneath its surface, making it a more promising candidate for the search for life and for future colonization. Projects such as the Mars colony proposed by SpaceX, aim to turn Mars into a habitable place for humans. Elon Musk even wants to create an artificial greenhouse effect on Mars. Whether this method of terraforming will be practically feasible is written in the stars. Theoretically, however, it would be possible. Venus is a billion-dollar grave. Do you know how many times Venus has been visited by probes? You won't believe it, but we humans have sent a total of 36 probes to this planet, but very few of them have been successful. The Venus missions included 28 Soviet, 6 American, 1 European, and 1 Japanese probe. In the 1960s and 70s, the then Soviet Union fired almost a dozen probes to Venus. A third of the missions failed, another third produced limited results, and a final third were really successful. Although the missions yielded some brilliant photos of the surface of Venus, we still don't really know much about this planet. The Venera probes that successfully sent images landed in different places. But now imagine if aliens landed probes at the Earth's North Pole. One landed in the ocean, where there was nothing far and wide. Another landed in the desert, or over an indigenous village in Papua New Guinea. What would the extraterrestrial researchers really know about our planet? They would know a tiny fraction, and that's exactly how we feel about Venus. The Soviet Union must have invested billions of dollars in its probes, and the yield was just a few photos and measurement data from the atmosphere and the surface. The USA also suffered tragic and, above all, expensive losses in connection with Venus exploration. Mariner 1 failed shortly after launch in 1964, and Mariner 3 was lost in 1964 due to a solar sail defect. Both probes together were probably worth millions, if not $1 billion. Early attempts by the Soviet Union to reach Venus often failed due to the extreme conditions in the Venusian atmosphere or technical malfunctions. These failures meant not only the loss of hundreds of millions of dollars, but also of valuable research time. Despite these losses, there were also successful Venus missions. The Soviet Venera 7 and Venera 9 missions in the 1970s, for example, were the first to perform soft landings on Venus and provide direct data from the planet's surface. Venera 13 and 14 provided the only color panoramic images of Venus, and the European Venus Express probe provided important data on Venus's atmosphere and weather phenomena. While these missions were successful, the amount and depth of data collected is limited compared to the extensive knowledge we have about Mars. Only the best land here. Landing probes on other celestial bodies is a feat. The atmospheric conditions, air resistance, and gravity on most planets and moons are completely different from those on Earth. Landing probes on Venus represents one of the greatest challenges in space travel. First of all, it's extremely hot on Venus. Surface temperatures of around 465 degrees Celsius and an atmospheric pressure that is around 90 times higher than on Earth put the probes under extreme pressure every minute they come closer to the surface. These conditions place enormous demands on the resilience and design of spacecraft, and the Soviet Venera probes are still regarded as technical masterpieces in this context. The atmosphere of Venus poses additional problems. Carbon dioxide and clouds of sulfuric acid form a dense soup that creates extreme aerodynamic conditions for probes on landing. The high entry speed generates enormous amounts of frictional heat, which has to be dissipated by heat shields. In addition, communication with a probe on the surface of Venus is difficult. The dense atmosphere and the great distance from Earth make signal transmission difficult. This means that probes have to operate largely autonomously, which increases the complexity of the missions and the cost of automatic control systems. In comparison, the conditions on Mars are much more favorable. The thin Martian atmosphere and lower gravity make it easier for probes to enter, descend, and land. What do we know about Venus so far? Let's take a look at what we know about Venus despite these difficulties. Basically, we're exploring all the planets in the solar system, and not just those that are potentially habitable. What we know about Venus so far is that it's the hottest planet in the solar system. This is strange because it is much further away from the Sun than the much smaller Mercury. And although the temperatures on Mercury are also hot, they are much cooler than on Venus. It is not only hotter on Venus because of its proximity to the Sun, but also because of the pronounced greenhouse effect. This was created on Venus by a dense atmosphere consisting mainly of carbon dioxide. with traces of nitrogen and other gases. This dense layer of CO2 traps the sun's heat and causes temperatures on Venus to rise to hostile levels. As there is hardly any water in the atmosphere of Venus, there is also no mechanism that could dissipate heat. In contrast, Mercury has no significant atmosphere that could trap heat, which is why it is significantly cooler despite its proximity to the sun. Another notable feature of Venus is its atmospheric pressure, which is about 90 times higher than that of Earth. This high pressure is also ultimately due to the enormous density of the atmosphere. The carbon dioxide presses heavily against the surface and would kill a human immediately. The pressure on the surface of Venus is roughly equivalent to the pressure we would experience on Earth from a water depth of 900 meters. This pressure is so strong that it would instantly crush solid objects, including human lungs and organs. The most exciting thing for scientists is the high level of geological activity on Venus. Volcanoes and evidence of plate tectonics have also led researchers to conclude that Venus was once similar to Earth. Even today, landscapes such as large mountain ranges, lowlands, and crater landscapes can still be found on our nearest neighboring planet. These features could indicate that Venus once had landscapes similar to our own. Computer simulations have shown that there could have been water on Venus several 100 million years ago. Where there is a wasteland today, there may have been oceans, forests, meadows, and possibly life on Venus. Subscribe now and never miss a new video.